Hello everyone, Ecotech here, and in this video I'll give you an update on the custom microgreen lights. So for the past week I've been working on the boards that interface with the power supply. You can see that I have received them here. Actually, I ordered them last week, so well, this week I've more worked on 3D models and renders and more ideas, but I've also tested this PCB that was designed last week. So on this PCB, you get to add a you wouldn't. I would solder on it the power connector, a switch, and two ribbon cable connectors. And this whole assembly would screw into a power supply, such that it basically does the interface and the adapter of your Meanwhile power supply. So if we see here, this is a typical computer or screen or your typical power cord. Then you switch it on and you'll see that this light turns on. Now the ribbon cable interconnection is fairly straightforward. You can just plug it, unplug it. And here you see this device, which is a ribbon cable extender. So this one, it's this board where you have a switch and two ribbon cable connectors. There's a simpler one, which would be just two ribbon cable connectors. On the switch one, well, it's fairly simple. It just interrupts the power if needed and propagates if you want it. So it's a switch. The idea being that you would put your power supply wherever you want. So let's say right now it's on the side and you want to run the power to the top shelf and then go down. So you run one ribbon cable that does all your top lights. Then the ribbon cable would stop here, and you would take this extender, put it there, add a ribbon cable that does all these lights, extender on this side, bring it down, and bring it all the way and daisy chain all these ribbon cable. And if for some reason your farm, for example, is not running full capacity and there's one shelf, well, half a shelf that you don't need, you could just put a switch in the middle of the shelf and decide to leave the three rows off while your timer is still turning on the power supply, which would turn on the three shelves. Actually, on this render, you get to see one of my main objectives with this light, which is to diffuse the light in such a way that you can bring them closer and take better advantage of the vertical space when you compare it to the old solutions where you need the extra space. In terms of the intensity of the light, this power supply is more than capable of delivering power to these boards up to the point where if you bring the lights too close to the microgreens, you would burn them. There would be too many photons. But this is adjustable. So if you see with this screwdriver, I get to just bring up the power, and trust me, this is very bright. I can't look at this. The camera doesn't do it justice. But so let me bring it back down, and this would allow you to really fine-tune the setting of the lights to the height that you've selected. Now, of course, when I will sell and ship these lights, they would be set to a fixed nominal value, which would be advertised within the data sheet that I'll build around this light. And I will also give the ideal hanging height depending on that level, as well as guidance to help you if you wish to increase the power or dim it according to which crops you're running. For example, sunflowers, they run pretty well on high power, but the pak choi, I've realized that they did a bit better, although they were leggy, they did a bit better under lower power. So this light will be very modular. Something else that I've noticed is that right now running 6 bars as I intended delivers more power than anticipated. Therefore, I'm contemplating running maybe 5, if not 4 bars per shelf. So more experiments to run to see if it's worth it. And the fewer the lights, maybe the higher the distance might be, but the cheaper it gets. So that's also something that you may decide. Like, you might really want a short gap, so you could plug in 6, if not 7 lights to get a very even spread of light, or you'd rather save a bit on the upfront cost of the lights and run 4 lights with a higher spacing. Something else that I've been playing with is if you look on this light, if it focuses, come on, focus, there we go. This is a magnet on the tip of it, and it's flush with the aluminum. The idea behind the magnet is to make it easier to just install the light. So this magnet is more than strong enough to just hold the weight of the light. Now this bar is too long, and the bar was set to this length because, as shown in the previous video, you could just slide it into here and it holds, and there's no magnets, and it's fairly simple. However, while using it, I've noted that sometimes I would bump into the light and they would fall. And this was a bit expected, and that's why there's 2 holes here to add zip ties. But adding zip ties is just very annoying to set up. I hate putting zip ties on the Sun Blaster lights. I find that very time consuming and just not a fun experience. So instead of putting zip ties, adding a magnet isn't a huge cost, and it's just a simpler user experience, where if you were to imagine that this board is 400 millimeters long, this one is 500, so it doesn't fit. But if it was a bit smaller and you had the magnets recessed, you could just take your light, put it wherever you want, position it exactly where you need it to be, and then put the ribbon cable connected, and that's it. So I think this covers most of what I wanted to show in this video. I'm still going, well, I still haven't done more power measurement tests. These new power supplies that I've been playing around with, mainly this one, should be more efficient than my previous tests, so I should get a better micromoles per second per watt score, which was already close to double what the Sun Blaster light gives. So very promising first results. The only small bad surprise I've had is that although the light is very good for the plants, because it's more powerful, the side effect is that they are shorter because they're not stretching to reach the light, right? And probably to mitigate that, the next time I will let the sunflowers be in the dark for an extra day just for the stems to get longer, and then put it under this light. Because after it's long, this light brings the other advantages, which is like the taste is better, it's crunchier, and it actually grows faster. And another side note is that although you might see a bit of mold over here because I've not attended them, overall there's a lot less mold on this shelf compared to this shelf, which has less light. So pretty excited to share this progress. This light is starting to really show some, well, I'm starting to really like it, although this is very subjective since I've been the one working on it. This being said, I'm currently gathering marketing material, trying to build data sheets and user guides to get this light to more people. So if you have a small audience, I might be interested in your help. The reason being is that to order these lights in a way that makes it worth it for everyone, I need to order a lot of boards to reduce the cost. At which point, the bill of material of that order will be significant, and right now I personally can't take such a big order. All this to say that I will work on a Kickstarter or an Indiegogo, and I might need some help in reaching out to more people and seeing if you're interested in this light. So yeah, that's about it. Thanks for watching. Take care.